Hello everyone, how are you all? So now next problems on gas laws. In the previous videos we had seen what are the measurable parameters for the gases. So pressure, volume, temperature, number of moles in the first video of gas laws, gaseous states. And second video we had seen the detailed study about gas laws. Those who not watched, you can find those videos in icon as well as at the end of the screen also you can see. And now in today's class we are going to see only problems on gas laws. How you are going to solve those problems. Okay na? So try to understand the concept easily. You will understand easy manner. So what the information we are getting from the questions and how you are going to solve the questions which are related to gas laws we are going to see. And most important thing is I will give you some assignment questions also on these questions. On this based on the gas laws, I will mention some assignment question in this video only. You try to watch till the end of the video and don't skip the video also. Okay, let's get into the video. So now what are the problems on gas laws we will see here. So first problem we will see a balloon is filled with 1 mole of helium at 0 degrees Celsius and 1 bar pressure. It will burst if pressure is decreased to 0.2 bar. That is what they are doing. They are decreasing the pressure. Indirectly they are increasing volume. Okay na? So when it is 0.2 bar, what is the maximum volume of balloon? At what maximum volume of balloon that balloon will be burst? That is the balloon will be explodes. We cannot say explode, it should be burst. Now you see here they are saying helium gas, same gas, 1 mole of same gas, that is number of moles is constant, and here what happens, it will be burst at 0 degrees Celsius, that is temperature is also constant. So number of moles and temperature are remains constant. So in which gas law we have T and number of moles will be constant? In case of Boyle's law. Now Boyle's law will have the water pressure, that is volume is inversely proportional to pressure. Volume is inversely proportional to pressure. So from this P1 V1 is equal to P2 V2 we will get. First what information we are getting from the equation we will see. Now here you see 1 bar pressure. Initially the pressure is 1 bar. Okay. And the volume also they not given. Just you take it as what V1 as V volume. Initially it is V volume. So at P2 final pressure will be what? 0.2 bar pressure. 0.2 bar pressure. So final volume will be how much? At what volume the pressure of the balloon will be 0.2 bar? At that 0.2 bar only balloon will be burst. Now you see in this case you substitute all those. 1 into V is equal to P2 is 0.2 into V2. So that is how much it is? V2 is equal to 1 by 0.2. 1 by 0.2. That is 1 by 0.2 is nothing but, it is 0.2 is nothing but we can write it as 1 by 5 we can write it as. Is it or not? 1 by 5 is nothing but 0.2. So that will go up. So fine. Okay. So now in some cases it is at 0 degrees Celsius. They are saying no. At 0 degrees Celsius any gas will occupy how much volume in generally? 22.4 liter. The gas volume will be what? 22.4 liter. Here it will be V, no? Now V2 is equal to V into 22.4 liter it is. At 0 degrees Celsius. That is what STP condition. 0 degrees Celsius is nothing but 298 Kelvin. Sorry, 273 degrees Kelvin and 1 atmosphere pressure. So at that temperature what happens? The volume will occupy in generally 22.4 liter. 5 into 22.4 you have to do. If they are mentioning in the options also, if they mention in terms of volume, that is 5 times the initial volume. If they are not mentioned, if they are giving particular values means V1 you have to take it 22.4 liter. Is that clear? I think so you got how you are going to solve the problems related to Boyle's law. Next we are going to see the problems related to the next one, that is at what temperature the volume of 28 grams of nitrogen will be 1 liter exciting pressure of 1 atmosphere pressure. At what temperature? They are asking the water to find the temperature. At what temperature the volume of 28 grams of nitrogen will be 1 liter exerting pressure of 1 atmosphere, which has 1 atmosphere pressure and 28 grams of nitrogen they are saying, which is nothing but what? It is a gram molecular weight, which is nothing but gram molecular weight of nitrogen. Gram molecular weight of nitrogen. Any gram molecular weight containing gas will occupy how much volume? 22.4 liter. So its initial volume is 22.4 liter. And its initial temperature is 273 degree Kelvin. That is at STP condition. At STP condition, these are the values. Now what they are giving here? Constant temperature. The constant pressure is constant and the mass of the gas is also constant. So here pressure and mass, that is number of moles, both are constant. In which gas law? Both will be constant. In case of Charles law, that is volume is directly proportional to temperature. So from this V by T is equal to constant. V by T is equal to constant. That is V1 by T1 is equal to V2 by T2. V1 by T1 is equal to V2 by T2. So from this you substitute here V1 T1, you know. What is the V2? At what temperature they are saying it becomes 1 liter. So T2 will be how much it is. Just you substitute and you do the calculation, you will get the water solution for that temperature. At what temperature the volume of the gas becomes 1 liter. Okay, initial volume is 22.4 liter. Just you take it as here, I will write here. So initial volume 22.4 liter by initial temperature is 273 is equal to, now the final volume will be 1 liter by final temperature we need to calculate. Then what happens from this? T2 is equal to 273 by 22.4 liter. Okay, so you can find the temperature here. So here volume is what happening? 22.4 liter to 1 liter it is changing. That is volume is decreasing means temperature automatically it will be decreases. You will get the very least value. Negative temperature you will get. Negative degree Celsius you will get. Is that clear? That is problem related to Charles law. I think so. You got some information about this. So next we are going to see the third question. Next we are going to see the third question. Now third question, what they are saying in that third question? So a certain mass of oxygen exert a pressure of P atmosphere in a vessel of volume V at 25 degrees Celsius. In the same vessel, what will be the pressure of a gas at 25 degree Kelvin they are saying. So they are changing the temperature from 25 degrees Celsius to 25 degree Kelvin. So temperature is changing. That is initial temperature is T1 is 25 plus 273. That is how much it is? 298 degree Kelvin. T2 temperature is how much? 25 degree Kelvin. 25 degree Kelvin. What they are saying? A certain mass of oxygen exert a pressure of P atmosphere. Its pressure is P atmosphere in a vessel of volume V. Okay. So what will be the pressure if a gas at 25 degrees Celsius, 25 degree Kelvin? That is pressure they are asking. Initial pressure is P. Final pressure they are asking to calculate. Okay. So we know the pressure to volume, pressure and the temperature relation. That is volume is constant and a certain mass, that is volume and number of moles are constant. When these two are constant, you have to look back to the Gay-Lussac law. Whatever the formulas which I had given there, Gay-Lussac law, those all formulas you need to observe, and which gives the relation between temperature and pressure, you have to take that formula. Pressure is directly proportional to temperature. P by T is equal to constant. So from this P1 by T1 is equal to P2 by T2. So P1 is how much here? P by T1 is how much? 298 is equal to P2 is how much? We need to find. By T2 is how much? 25 degree Kelvin. 25 degree Kelvin. So from this P2 is equal to what happens? 25 into P by 298 Kelvin. That is what they are doing. They are decreasing the temperature from 298 Kelvin to 25 Kelvin, then pressure automatically it will be decreases, you will get very least value of pressure. Is that clear? So that is third question. Is that clear everyone? So if you want a round figure, you take it as a round figure, it is a 300. So 25, how many times it will be? So 25 12s are 300. Is it or not? 25 4s are 100. 25 8s are 200. 25 12s are 300. Okay, P by 12 it will be. P by 12. Initial pressure, 1 by 12th of initial pressure it will be. Okay. So next fourth question we will see. A gas cylinder with stands a pressure of, one gas cylinder is there which is having initial pressure is how much? 14.9 atmosphere pressure. Its pressure gauge indicates 12 atmosphere. Initial pressure is how much? 14.9 atmosphere initial pressure. So it is indicating in after some usage, it indicates that pressure gauge indicates 12 atmosphere. 12 atmosphere. Some quantity of gas is utilized, then its pressure is automatically decreases. At 27 degrees Celsius, if the building catches fire, suddenly if the building catches the fire at 27 degrees Celsius. So at what temperature the cylinder explodes? At what temperature the cylinder will explodes? Now T1 temperature is how much? 27 degrees Celsius. 27 plus 273, that is 300 degree Kelvin. So at what temperature the cylinder will catches the fire? At what temperature the cylinder will catches the fire? You take the water pressure and volume, pressure and temperature relation. Here the volume of the cylinder will be remains constant, and the number of moles of gas which is present there, number of moles will be remains constant. That is pressure and temperature relation. Pressure is directly proportional to temperature according to Gay-Lussac's law. So from this P1 by T1 is equal to P2 by T2. So from this P1 is 14.9 by T1 is how much? 300. So P2 is 12 by T2. So from this T2 is equal to 12 into 300. 12 into 300 by 14.9. Okay. So you do this one, you will get the exact value of temperature. Its value will be around you will get, after converting into degree Celsius, you will get 99.9 degrees Celsius. 99 degrees something you will get, point something. 99.5 degrees Celsius you will get. You will get in degree Kelvin. That degree Kelvin you need to convert into degree Celsius. So next we will see some questions related to graphs. Graphs related question you see. These graphs related questions are somewhat important, because in so many exams they are asking the graphs based on gas laws, so which is one of the important one. Now first graph you will see. Now they are giving the water volume versus temperature axis they given. Which law it is? Volume versus temperature. The graphs which are plotted between volume versus temperature at constant pressure, those graphs are said to be isobars. Those graphs are said to be isobars. How we can define the isobars here? The graphs which are plotted between volume axis and temperature axis at constant pressure, they are said to be isobars. Now what is the relation between pressure here? P1, P2, P3. At constant pressure P1 we are getting this curve. At constant pressure P2 we are getting this one. At constant pressure P3 we are getting this one. So now what is the relation between those three pressures? Now if you want to find that relation, you draw any perpendicular line to the x-axis or y-axis you can take. Now I am drawing the perpendicular line to this x-axis. Okay. So then what happens at P3 pressure? At P3 pressure, whatever the volume is there, no, that volume I am mentioning as V3 volume. So at P2 pressure, this is P2 pressure, whatever the volume is there, that is I am mentioning as V2 volume. So at P1 pressure, the volume will be V1. Now what is the relation between this volume? Which volume is more here? V3 is more than V2 than V1. Is it or not? So when you are going from this side, the volume values will be increases from origin to upper side, that is height, that is volumes are more. Now what is the relation between pressure and volume? We know that Boyle's law is there. So volume is inversely proportional to pressure. Volume is inversely proportional to pressure. Volume increases means pressure decreases. At V3 is highest means at V3 whatever the pressure is there, that is very least one. That is P3 is least one. After that at V2 whatever the pressure, P2, P1. V1 is very least. V1 containing pressure will be very high. That is P1 is very high. After that P2, after that P3. So I think so you have understood. So how you are going to do from the graphs. Now the term isobar is very important. Now you see in this case, now we are plotting the graph between pressure versus volume, 1 by volume. It is also what? Boyle's law. It is in Boyle's law. At constant temperature we are plotting the graph. Now whatever the graphs which we are plotting between pressure and volume at constant temperature, those graphs are said to be isotherms. Those graphs are said to be isotherms, which I had explained. Once again I am saying in the graph itself. Yeah, now you see here we are taking the perpendicular to the x-axis, 1 by volume axis. Then what happens here at a T1 temperature, whatever the volume is there, whatever the pressure is there, that is P1. At T2 temperature, whatever the pressure, P2. At T3 pressure, at T3 temperature, whatever the pressure is there, that is P3. Now what is the relation between P1, P2, P3? P3 is more than P2 than P1. So in the same way we know that pressure is directly proportional to temperature from Gay-Lussac's law. So there whatever the temperature at P3, that T3 temperature will be very high. After that T2, after that T1. Is that clear? So next we are going to see the graph which is plotted between log V versus log P. When we are plotting the graph between log V versus log P, what type of graph we are going to get? So when they are given log in terms of log, first you need to know what the relation they given, volume to pressure. So first we need to find that relation. Volume is inversely proportional to 1 by P. Volume is inversely proportional to pressure. That is PV is equal to constant. PV is equal to constant K. Just you apply the logarithm on both sides. So log P into V is equal to log K. On both sides I am applying the logarithm. So you separate this log PV into log A plus B form. Log P plus log V is equal to log K. So this log V is on the y-axis, so keep it here. Log P you send that side. So log V is equal to plus log P, if it is goes that side, it becomes minus log P plus log K. Okay, so it is just you write it as minus 1 into log P. Again you will get same, just for y is equal to mx plus c form it is. On y-axis what we have, log V is there. On x-axis what we have, log P. So now intercept will be log K with negative slope they given. Negative slope means we are going to get the curves like this, downward direction. It is what intercept C, that is equal to log K. So now here it is what slope. Slope will be what happens? Slope is how much? Minus 1. Now how you are going to calculate slope here? y2 minus y1 by x2 minus x1. That you will do in mathematics. So by using that formula you can calculate this slope. So that's it, the problems on gas laws. So you will find the more number of questions, assignment questions here itself only, in this video only I will mention. So in that total of, in this video, in this assignment contains different questions with options also I have provided. So with answer I have provided, you try to solve it if you know. Okay, otherwise if you are not able to do those problems, you mention in the comment. I will definitely try to give you answers. Thank you. Have a nice day. Keep watching Upper Chemistry classes. Thank you.